Hi, I'm Noah Hiles.
I'm Tyler Manier.
And we're going to talk about geology on the moon. Our question was, is the geology of the moon similar to the geology on Earth? We're going to go through, this is just a little outline of the whole presentation. First, I'm going to outline moon geology. Then Tyler's going to go over the history and formation of today's moon geology, how the moon got that way, and why. And Graham's going to finish it off by comparing the geological features of Earth and the moon today, and say if they're similar or not. We'll start off with the moon. The moon is 263,000 miles away from Earth. Because its size, it is the closest it can get is 220,000 miles, and the furthest it can be is 255,000. So the average ends out, like I said before, at 263,000 miles away. Diameter's roughly 2,160 miles, which is 1/4 of the Earth. So example, it takes 29.5 days to go all the way around Earth once, and it only took the Apollo missions roughly around 3 days to get around the Earth. Just continuing some moon facts, excuse me. Moon rocks, the oldest ones, could go up to 4.3 billion years old. So it definitely has a lot of history with the rocks, and they've definitely changed, but some don't change. And the moon's orbit lies neither with the equatorial or edaphic plane. So it has a unique orbit. Now, Tyler's going to go into history.
So next we're going to talk about the history of the moon. Obviously pretty important when you want to know more about the geology. When we talked about the Earth in class, we went back through different periods and saw how like the climate and everything was different during the time of the dinosaurs. And so that's important here as well. First thing we're going to talk about is it formed shortly after the Earth, so it's about the same age. There's different theories as to how the moon formed, some more popular than others. We'll talk a little bit about that in a minute. Next, the Apollo missions definitely had an impact. Before and after the Apollo missions, we had a very different understanding of what the geology and just what the overall surface of the moon was like. For example, some scientists believe that the moon formed in the early solar system, and then after we got lunar samples and other missions after the Apollo proved that this was not the case. We also learned a lot more about the moon. It also has a thicker crust on one side. This is due to the Maria, I believe it's called, and it's basically vast pools of solidified basaltic lava, according to NASA.gov. And the moon consists of a lot of volcanic rock and has a composition similar to the Earth, however on a much smaller scale. So like they have a mantle and a core and all that, but it's I think 15 times smaller than the Earth. So some of the theories for the origin of the moon. There's 4 main ones, although other less popular ones exist. The first one is the theory of fission, which is basically the idea that the moon originally formed as part of the Earth but torn free for some reason. The next one is the theory of co-creation, which is that the moon formed pretty much exactly how it is today. It formed in its present orbit surrounding the Earth. The next one's kind of similar to that, the theory of capture, which is the idea that it formed as a separate planet but then it got picked up by the Earth's gravity, and that's why it's in orbit around us. And then the last one is the most widely accepted, and that's the impact theory. So imagine a Mars-sized planet comes in and hits the Earth, causes a lot of damage and a lot of debris. You can't really see it here. There's an artist's depiction of what may have happened. But Mars-sized planet comes in, hits the Earth, causes a lot of damage and a lot of debris, and then that debris sticks around and comes together and solidifies into what would eventually become the moon today.
Okay. So I'm going to talk about lunar geology. There's 2 types of terrain on the near side of the moon. It's Maria and Terre. That, as Tyler already mentioned, the Maria is the smooth, dark lava flow, and that's on the that causes a thicker crust. And then the Terre are the highlands that are completely covered with craters. On the far side, there are large basins or craters that aren't filled with lava, and then impact cratering is what I'll go into later. That's when asteroids strike the moon, and that creates the most craters on the moon and kind of depicts its surface. All right, so just a comparison to Earth to the moon. For this, I just wanted to show how much smaller the moon is in comparison to the Earth, and that plays a big role in why they're so different. Alright, so as we know from geology class this whole year, the Earth is shaped through weathering and erosion, whether it be mechanical and chemical, through water, glaciers, wind, anything like that. Whereas the moon is shaped through meteor impact, and so two kinds of craters are formed, primary and secondary craters. Primary craters are formed from direct impact of an asteroid when it strikes the Earth, or the moon, I should say. And then secondary craters are formed when pieces of that first impact break off and then create smaller secondary craters. The moon is also covered in regolith, which is loose dust, soil, and broken up rocks that cover the majority of the moon's surface. Alright, so some similarities between the Earth and the moon. They have similar oxygen isotopic ratios. Both the Earth and the moon, as Tyler mentioned, have solid and liquid inner and outer cores, and then very thick mantle with a thinner crust. And the Earth and the moon both also have atmospheres. The lunar atmosphere was experimented on during the Apollo 17 mission, and it was found that the three most abundant gases in the moon's atmosphere are neon, helium, and hydrogen. Alright, so now some differences. The moon is very dead, whereas, as we know, the Earth is a very active planet. The moon is dead because of its size, so much smaller, and there's a lack of radioactive decay materials on the moon, whereas the Earth there's bountiful. The moon's surface is made up of mostly craters and ridges. As I said before, it's shaped by asteroid impacts, whereas the Earth, as I said, was shaped by weathering and erosion. And the main difference in the moon and the Earth is explained by the mass of the two. Because Earth is so massive and there's so much radioactive decay material, a lot of heat is generated, which liquefies rocks. When the rocks are liquefied, that drives crust activity. Since the moon is 80 times less massive than the Earth, the heat it generates isn't enough to liquefy rocks, so therefore there can't be any crust activity. So in general, the moon is a very dead planet because nothing's really going on.
So, in conclusion, though our studies of examining the similarities and differences in geology between the moon and Earth have determined that there are noticeable resemblances in some aspects, we found that through the Apollo missions and everything else, there are more differences in geology between the Earth and the moon than there are similarities. So overall, we would say that, yeah, it's kind of relative, but the geological features are kind of separate altogether. There are sources, and thank you.
Questions?